Today's printed circuit board designs can be extremely complex and highly dependent upon good thermal design considerations. It's an area where AI can assist developers and create better designs more quickly. Cadence's AuraStack AI Super Agent builds on its ChipStack AI Super Agent. AuraStack is designed to streamline creation of printed circuit boards and advanced packaging designs, and it can cut the time to market in half while increasing productivity by an order of magnitude. So how about we check out a quick demo of AuraStack to see how it would work.
Introducing AuraStack, the world's first super agent for electronic system design. We will show AuraStack's capabilities using a 5G smartphone design consisting of a 66-page schematic and 10-layer stackup. The next version is being cost-optimized to target a new market. On a design like this, power management margins can influence cost, so the approach requires understanding the power margin, then optimize for cost. Let's see how AuraStack, working with the designer's choice of frontier large language model, can dramatically speed design creation, optimization, and analysis. The designer will ask AuraStack to describe the design. AuraStack summarizes the design, helping us understand its structure. As the power margins will have impact on our design and cost, the designer will have AuraStack check for IR reliability with pre-layout analysis. AuraStack guides us to the power management IC. As this is the primary PMIC, the designer will have AuraStack create a power tree that can be simulated in PSpice. AuraStack develops a plan to create, simulate, and present the power tree analysis. With that information, the designer will begin optimizing the bill of material for cost. He will start by prompting AuraStack to generate a bill of material for this design, focusing on discrete components. The designer can simply ask to have the bill of material for this design optimized, as AuraStack is supply chain aware, and the designer is presented with opportunities for improvement. AuraStack recommends consolidating components based on package type, which will result in 28% cost savings. The designer continues conversing with AuraStack to further improve the cost by finding a lower-cost, pin-compatible power management IC, U6, based on the more accurate margins determined in our power tree analysis. AuraStack presents multiple options and an optimized recommendation. Satisfied with the alternate part, the designer prompts AuraStack to replace the PMIC U6 with a lower-cost, pin-compatible device. AuraStack determines the library model is missing and initiates the library creation agent to build a new symbol for the component based on the PDF datasheet automatically, creating the component and updating the design. Notice AuraStack is aware of best practices and recommends to the designer to run a complete design audit. Taking the advice, the designer runs the schematic audit. The audit is completed and the results are presented. It flags a few graphical issues, nothing structural, so those are waived by the designer, and the designer moves on. Next, the designer requests an MTBF analysis. AuraStack estimates mean time between failure rate for components in the design. The result? 21 years versus the designer's 20-year target. The cheaper design still meets the design requirements. With the schematic verified, the designer proceeds to layout trials. The designer chooses to have AuraStack use its placement agent to automatically verify the stackup and optimally place the components. After automated placement is complete, AuraStack advises a thermal analysis be performed. The analysis reveals hotspots and recommends placement changes to the designer to satisfy the thermal envelope. After adjusting the placement to address the thermal issues, the design is ready to route. The designer asks AuraStack if there are any high-speed interfaces, such as MIPI diff pairs. AuraStack finds several unrouted nets, and the designer elects to have AuraStack auto-route one of the MIPI clock nets using the current constraints. With this successfully completed, the designer asks AuraStack to route the remaining nets and check for DRCs. After successfully passing DRCs, the designer prompts AuraStack to perform an IR drop analysis on the 3-amp battery voltage rail. The analysis completes, and the result is satisfactory. Finally, The designer wishes to evaluate signal integrity analysis on one of the high-speed signals routed. AuraStack extracts the topology first, then simulates, and the eye-opening meets spec.